Greetings, mathematicians. In this video, we're going to continue our work with solving equations, but we're looking at some special cases. So sometimes you'll go through all of the work of solving your equation, but instead of getting something like x equals 4, you're going to get something like 4 equals 4. And that means that you've come up with an identity, or something with an infinite number of solutions. And you will write one of the following, either all real numbers, infinitely many solutions, or this symbol that looks kind of like a double R. And what that means is every number that you plug in for the variable will give you a true statement. Or maybe when you go and you solve the problem, instead of getting a true statement, something like 4 equals 4, maybe you'll get a false statement, like maybe you'll get 4 equals 5. That means there's no solution. It doesn't matter what you plug in for x, you're always going to get a false statement. When that happens, you're going to say something like no solution, or this special symbol, it's like a 0 with a slash through it, which means no solution. Or you can also write something called the empty set, which is like a set of curly brackets with nothing inside of it. All right, so here are our examples. Again, we're just going to be solving these. We're not going to write down the properties, although you should probably be thinking about those in your head as you go. You should be able to justify any step. So, as we begin here, on the left-hand side, we have some like terms. We have a 1x minus a 2x, which equals a negative 1x, or just a negative x, or the opposite of x. That reasoning would just be combining like terms. For your next step, we would try to get all of the x's on one side of the equation by adding x to both sides. And something interesting is going to happen here, because the opposite of x plus x, that's using our addition property of equality. Negative 1 plus 1 is 0, so that's our additive inverse. And then that's just going to give us a 3 on the left-hand side of the equal sign, because 0 plus 3 is 3. So we're using our additive inverse and our additive identity. And actually the exact same thing happens on the right-hand side. We've got negative 1 plus 1, which is 0, and then 3 plus 0, which is 3. So again, using the additive inverse and additive identity. And instead of getting something like x equals 3, we get 3 equals 3. So this is an identity, which means the solution is all real numbers. Now, in terms of checking your work, there's not an easy way to check your work when there's an infinite number of solutions or there's no solutions, other than just to go back and look at your work again and make sure you don't have any obvious errors. There's no number easily that you can plug in for x, although you could maybe try a couple of different things, like think of some different numbers here, and in reality every number you pick should go in and give you a true statement. Like if I plug in a 5, I should get a true statement. If I plug in a 7, I should get a true statement. So you can try a couple of things and make sure it always works. Let's try this next one. So for this next one, I have some distributing that I can start with. So my first step was the distributive property. Next step, I'm going to try to get all of the x's on one side of the equation only. So I'm going to accomplish that by adding 4x to both sides. So I use the addition property of equality by adding 4x to both sides. On the left-hand side, I did negative 4x plus 4x and got 0x. That's my additive inverse. And then 0 plus 12 is 12. That's my additive identity. Next step, I'm going to divide both sides by 3, and that is going to give me 4 equals x. So I did my division property of equality. Dividing by 3 is the same thing as multiplying by 1/3. So 3 times 1/3 on the right-hand side, giving me a 1x is my additive, or is my multiplicative inverse rather. And then the 1 times x just giving me x is my multiplicative identity. So I do actually end up with an answer for this one, not all real numbers or no solution. So I can actually check this one by going back to the original problem and plugging in the answer that I got and seeing if I get a true statement. And I get -4 equals -4, so that one is correct. Moving on to my next problem, I have a distribution problem again. And then I'm going to try to get all of the variables on one side only by adding 6r to both sides. And when I do that, something kind of weird happens. On the left-hand side, I've got -6r plus 6r, which is 0r, and then 4 plus 0 is 4. And on the right-hand side, same idea, except for 12 plus 0 is 12. So I get this false statement. 4 is not equal to 12. So there's no solution here. Again, not real easy to check this, other than that every number you plug in for r is going to give you a false statement. You could also maybe check this graphically by trying to graph both of these lines on something like Desmos and seeing that they never cross. That would be another option for you as well to try to check your work. And then our last problem, we have remember you can think of this as like a -1 to distribute. And then that's our distributive property. And then we have some like terms to combine. Now we're going to try to get all of the variables on one side only. So I'm going to subtract 3y from both sides. So I did the subtraction property of equality, additive inverse, and additive identity to get to here. Now I'm going to add 4 to both sides. Okay. Addition property of equality, additive inverse, and additive identity to get to here. Divide both sides by 2. So that is division property of equality, multiplicative inverse, and multiplicative identity to get to this point. And since I've come up with a numerical value, I can try to check my work by going back to the original problem and trying to plug in the 5 for the y and seeing if that comes up with a true statement. And then we do get 21 equals 21, so that is a true statement, so I know that my work is correct there.